So good afternoon, everybody. It is a pleasure to be here. This story that I will go through is actually going to be a mix of explanations of where we see and how the different technologies are transforming our society, different kind of vertical industries. We could actually use different kind of takeaway messages as the title of the presentation as well. I could easily write over there that as a recommendation, plan your transformation first, digitalization and digital second. We could also write as a title of this presentation something like how the algorithms will improve our capabilities to manage our society and our business. And if you want, we can delve into the in-depth of artificial intelligence, all the kind of neural networks underneath, and the different kind of models of them. There's about 30 of them maybe. We could delve into the blockchains. We could delve into the consensus mechanisms underneath. I will not give you too much of a pain point in terms of the technological area, the layers over there. Instead, we will take a look at how artificial intelligence, Internet of Things, the different kind of buzzwords you might hear in terms of cloud computing, mobility, how they begin to shape the way that we are getting organized. A few words of Fujitsu in the beginning. We are a technological company. There's about 150,000 of us across the world. We carry nearly 100,000 patents, which basically gives us a kind of indication that we do have a lot of research done in the company. We are present in about 100 different countries, and we spend about 1.6 billion US into our research and development activities on an annual basis. You might basically know us from some quite typical products, something that is sitting on your desk or carried in your suitcase. You might know us or some of the infrastructure platforms that are operating in the data centers or the services around them, but anything I will show you today is actually an outcome of our R&D. So the elements over there are technologies that we are developing and providing for our customers. Not everything is necessarily something that is completely commercially available yet. But so you need to drive and create the bridge into your own operations of what that will begin to mean. But everything that we will give you as an examples are actually something that we are working on. As a Japanese organization, we have a quite clear cultural view of what the technologies will mean. 30 years in IT infrastructure and different kind of technologies that we've been developing since the early eras of ferrites and then the mainframes thereafter are now at the phase of industry, which is typically a 60-year cycle. We are in the middle of it, where it begins to get embedded everywhere. So the technologies we deliver, we are more now interested in how we can deliver common good with it. So how the digital technology becomes to have a foundation role in solving global challenges that we have in our society and of course in the marketplace, and empower the people to build themselves a more safer, more prosperous future. So that maybe carries a little bit of a characteristics. When we set up a supercomputer, it will be doing some calculations towards finding the molecules that might be used in a medicine to fight against cancer. So we leverage the technology we have in order to do some common good. The digital disruptions over the year have actually been built in waves. And I don't really strongly like the word digital. Half of myself being technical, I really enjoy delving into the depths of the different kind of technical details that are there. But then my other part of my head keeps echoing that digital is not better. Better is better. So you need to figure out the better first. The digitalization will follow. That will be built on your innovation capacity. So this is not a quest for technologies. This is definitely a question to you, what are the factors in your industry, within your proposition to the marketplace, or your role and function in the society, among the target customers that you have, what are the factors that can be enabled by digital to drive value add that allows you to reposition your company or your organization or your services in the marketplace. And that basically, yes, it does bring along all the different kind of technological waves, but this is not the question, this is not the seeking for a given type of a technology. When talking about Internet of Things, I get a lot of dialogues that start from, do we need to add a certain type of a sensor somewhere? I'll show you the role of the sensor in the end of the presentation, where that actually sits in the whole scheme. And that has a very minuscule role in the whole end-to-end value that can be created. Artificial intelligence is the first one that we need to begin to discuss. The algorithmic world starts from all there. It gives us the ability to understand the world like a human person. So when I was a young person like that, I remember with my neighbors, some kids around, standing in the street, looking at the passing cars, and then we were trying to guess 100 meters before that that's going to be a Volkswagen, or that's going to be a, at that time, Opel, or it would have been some other type of a brand of a car. Artificial intelligence gives us the ability to have a method to sense like a human person. So we can actually, as you saw in the video that was running on the slide at the back of it, we can actually do pretty much the same as we could actually achieve with a young kid standing somewhere on the side of the street and giving us information. It just happens to be that the scale of the technology is far stronger. So with one single camera, you can actually follow a parking slot with 100 different kind of parking spaces in it. Compared to installing sensors underneath every slot, there's just one bird's eye view camera. You never draw into a graphical information system the geolocations of those parking lots. It is the software that, like you would be, standing on the roof, looking downstairs, you begin to learn. Aha, they stop a car over there, there must be a parking slot. After some statistical, let's say, calculations, it begins to mark that geographical area as a green parking slot. Therefore, sometimes the geographical triangles and squares over there are not exactly sharp. It then begins to kind of derive the same understanding as we had. Is that slot free? Or is it occupied? Or should I inform maybe mobile application users of the capabilities of you to come over here and find a free slot? So we can provide occupancy information to drivers. We can, of course, monitor the license plates as well. The recognition of a character like that is relatively simple, but we can also detect any suspicious behavior. So it's like you standing on the roof. You can detect a parking violation, somebody stealing 2 slots with one car. You can, of course, check the overtime. So now it becomes the kind of elements of what do you do with that human sense that artificial intelligence gives you, that kind of allows you to understand what the transformation here is. There is the digital underneath. It could be a sensor as well, but it happens to be over here video because it shows you the power of a relatively simple today's technology called CCTV, a simple camera. That using a software to read the camera video stream, you can actually derive an understanding that is equivalent to that young kid. Now, that is one element of a transformation. We are currently seeing this being deployed to understand the consumer behavior in a petrol station. Basically doing the normal counting. So how many vehicles? What are the types of the vehicles? What are the classifications of them? What are the brands of them? How many minutes did they spend in the queue? How many cars do we need to have in the queue before the last car actually drives off and goes to another petrol station? How many of those customers actually visit the shop inside? How many people do we have in the shop in general? How much does that compare to the amount of cars we have in the pumps? Is there how many cars are actually not buying petrol but are only coming to buy some goods from the store? The store value has a margin that is that high. To buy something quickly when you pay for your petrol, the accessory products carry a smaller profit margin for the petrol chain, and the petrol itself is very thin. So there is a reason that they want to understand the consumer behavior and drive through the kind of analytical capabilities more and more customers into the shop. But for that, they need to understand how we behave. It is an equivalent of a store manager standing in the outside and directing customers and trying to recommend them to come in. This is still, from artificial point of view, Boolean. It's kind of a yes and no. It's kind of a rule-based. It's kind of a relatively simple conditions that we can use on it. So getting that intelligence of digitalization further, you need more data. And that's what Internet of Things actually brings us. It helps us to process vast amount of real-time, sometimes numeric data. In the next example, it will be continuously to be about location data. So what happens when we put artificial intelligence and Internet of Things together and begin to look into the next capabilities of us as a human? Our ability to plan, our ability to predict, recommend, and support decision making in a larger scale. So we take everything that you can imagine as IoT, rail data, road data, buses, taxis, pedestrians, weather, accident, venues, location data, and put that together. And then we begin to run a city in a little bit different manner. Looking at the real-time traffic conditions in a city, you can see over here in that image the kind of a current status of highways. You can see the current status of railways. You can see the current status of bus lines. Now that real-time information of us knowing where the bus is gives you the opportunity for multimodal transportation, let's say a routing and journey planning, that instead of you taking the bus number 15 and then at the railway station taking the rail, let's say IC number 15, it doesn't help you if the bus is late. You will miss the connection. Over here, we have the ability to deliver you a real-time journey plan that tells you, don't take that bus, take actually the bus number 8 instead, go to another station, because with that, you will reach your destination in your given time. Should your profile be different, you can set that journey planner to give you the ticket that has the cheapest price, that delivers the least of CO2, or gets you there fastest. That is something with all the vast amount of Internet of Things data with analytical capabilities that are above the Boolean capabilities of artificial intelligence, but where we begin to actually use it with the ability to predict, plan, and look at real-time conditions in a different manner. Of course, you can have the congestion detection over here as well. We have already algorithms that understand if there's a car crash somewhere as an accident, what is the impact in terms of the congestion that it might create, what is the area of a footprint that the congestion will have an impact on, and how long will it take. And then there are, although from a readability point of view relatively blurred, over here there are recommendations. The recommendations could be that add another bus number 15 to the line for the next hour, because that's the only way that we can get rid of the congestion over there. The city begins to provide a promise to the citizens that the public transportation will never request you to wait for the connection for more than 3 minutes. They just need to have the real-time awareness of the current situation over there. When there's a rain shadow somewhere in some part of the city, we can inform the taxi companies half an hour earlier that you might want to go over there, because we expect that a certain amount of new customers will be looking for a taxi drive in that area. So all that capability built into a relatively straightforward artificial intelligence type of a system. Now let's see if we have some more insights to that. So here you actually see that type of a system. You have the transportation information over here. You have the railways. You have the actual taxi information. I can go and look into, even if I want to, I could begin to jump into the city and begin to dwell inside of that and look at the given area. The areas are extremely interesting if there's a big venue, like there would be a national football team from Iceland playing against whoever wants to lose. Thank you. To know that the 70,000 people, and knowing that there will be 50,000 hooligans from England on it because they lost the game, they get out. So you can set up the security personnel outside the stadium to direct them that you guys coming out of that gate from the stadium, you go to that direction. You distribute the people so that there is not a high congestion of people in one area. From transportation point of view, that helps as well. We can further take that deeper by adding marketing capabilities on it. The marketing allows us to send coupons to people saying that, well, since you are so desperate, why don't you come over here, have a pint of beer? So the local companies can actually leverage the fact that there are 70,000 people coming out. From transportation point of view, that means that we will level out the peak that otherwise would occur over there. So this is basically adding IoT and AI together. This is no longer Boolean. This is no longer just simple rule-based decisions. This is something that integrates all IoT data with statistical reasoning, with abnormal detection of events and extrapolation. We can make the system to we have a harbor system for harbor management, where similarly we look at the vessels that are coming into the harbor. The harbor manager actually is looking into the future. The screen in front of him is 30 minutes ahead, so that there's time to call the tanker that you need to slow down, because you don't have the ability to maneuver 180-degree turn in the harbor to get into the pier, because we have another vessel coming in. So he needs about 30 minutes before that is cleared. Now, let's take the next part from over here. And as you can see, I'm running a corporate PC, and the corporate PC is always managed. And up over the left in the upper corner, it has decided to do a small update. This is only because I want to run these demonstrations really in real life to you, not only so the slides, and it's never recommendable to do beta software demonstrations in front of an audience. Never mind that. Now let's go further into a business process transformation. So we already had the AI, we had the IoT. Now we are getting into a part where we are interested in the ability to learn. We are interested in the ability to discover and process knowledge. Using visualization of all the possible data you can imagine, so that you create a digital twin of a global manufacturing operations. That digital twin gives you real-time information of everything. It's kind of an X-ray vision into the whole operations on a global level. And that kind of global level helps you to improve your productivity of that. It's algorithmic business environment, operating model, it's performance indicators that are completely new, and a management model. So let's take a real-time view of that and just ignore that upper left corner. So you have about 36 factories on the screen at the moment. They are all over the world. There's a map that shows their location. You have the normal bars of with data. We have the issue that we need to have the ability to transform the essential information of a data in 2 seconds to your eyes. So how do you interpret it and read all the data from all the factory operations over here? So there's a set of new KPIs created. As you can see, disposed material, there's a good production, there's the workload that they have in the factory, and you have the equipment efficiency metrics. You have the normal ERP system statistical data or numerical data from your sales systems and others. That, of course, needs to be crafted out nicely. But you have new KPIs as well, like the amount of toxic substances that the company generates, the amount of CO2 that this company generates worldwide in its operations. Now, how many of you in your own organization currently have the ability to report something like that. You can go from over here into a performance comparison. So we take a regional view where you have a Japan, Asia, United States, Europe, China as a kind of a region with the same KPIs as you saw accumulated on a global level, now looked from a regional point of view. So we know who is actually performing better than another region. Now the management dialogues, therefore, will be completely different hereafter. So here we go. Looking into a single factory, let's go back to this nice yellow warning over here. That's Shiga. I get into the factory, all the numerical data is still there, the KPIs, but now applying to the single factory. You have a little bit more information of the fact that there are 30 lines on it, 28 of them are alive. The production level is quite high, 99.6%. We have 500 employees in place with 22 or 23 experts, and there's some additional information available. Into the factory, X-ray, 3 production lines, A, B, and C. The efficiency of energy, the efficiency of the equipment over there, calculation of CO2 per customer order. How many of you can give a document to your customers that once you brought this product, this was the CO2 that came with it? And you have, of course, the different kind of other metrics over there as well, but you have also the warning sign that even the global supply operator and vice president was seen as a yellow sign that there's something frozen in lane A. We get into this production lane A, and those of you who know manufacturing processes might figure this out. This is a surface mounted board line which has 5 different machinery in the production, which means that the goods come in from over there, and then there are 5 systems that it goes through, and then you have a finished product. Now, it clearly have an issue over there. One of the issues is that some of the systems have been frozen. So we can go deeper. Let's use the X-ray more. Let's get into a single machine. And it has some sort of warning. I get into the warning, and over here it tells me that the luminance sensor doesn't have the ability to pass through the light above the threshold level. And I told you that the dialogues that I typically have in this industry starts from the word digital. The IoT dialogues start from the word of a sensor. Well, it is here, but it has a little relevance to thinking about the transformation first. You can add these sensors as much as you want, and you still haven't figured out how will you run that factory operation as a machine engineer. How will you run your operation for your production line manager? How will you run your business as a factory director? And how will you run your global operations? That's transformation. Completely new KPIs, different kind of a way of managing the company, and different capabilities that didn't exist there before. That's unprecedented, kind of an unprecedented visibility into the operations with new type of a analysis, new type of a visualization. And it doesn't take more than 2 seconds to understand where we are. Yes, you can still use Excel if you want to. Another vertical, since the financial services sector happens to be something of a quite big in this country, and kind of a famous of it as well. Let's go into look into the kind of a complex behaviors that digitalization allows. The transformations that in the financial industry are kind of foreseen when you have the ability to identify the relevance of data that comes from multiple different kind of sources. So the graph analysis is typically the method. So we collect information as a metadata being managed in between that has linked open data. So anything you have of a company, let's just pick it up. It's somewhere, it's stored somewhere. One of those sources, of course, are the official financial reports that the public companies need to report to the authorities. Let's read them all in. Let's read all the stock prices in that the company has. Let's read in all the customers' private data, the press releases, the annual reports they have. Let's read the newspapers and see what has been written from that company. Let's read the social network world and put that together. Now you begin to see a complex data management problem. You can do this as a human person, but you don't have the scale to read everything. So in order to read everything, to kind of understand from something from a company, let's take a look at Citigroup. One of the interesting pieces is to understand who is Citigroup connected to. So over here you have a relationship. So nothing is being written, nothing has been stored by human persons as a data entry. This is automatically derived by reading the list that I mentioned or different kind of sources of data. And then we have actually a view of who is this company connected to, which is graphically represented again a little bit differently in order to communicate this to you in 2 seconds. This company happens to be connected to this small other company over here. And if somebody wonders what is the shortest path from there to another customer that they might have, that's relatively easy to find. Now we have a bubble that tells that the Bank of America is connected to Citibank, and you have all the relationships built in it. Actually, you could go further. You could go to and look at a key person like this. How do we learn this? Let's take a look at Diana. Well, Diana is an employee of Citigroup. Group, but only since 2015. We have already learned that actually she was working for Sotheby's, and she still carries underneath the Sotheby's 24 connections that are alive according to the system analytics that we've done. Now we use this to detect frauds in financial services in terms of stock purchases. Somebody has a connection, so there's a good, strong believe to expect that there could be, as an example, exchange of insider information. All that could be derived by simply looking into the different ways that we can use data. We have, just for the curiosity of it over here, onto the left, I made a view that can be easily used by different kind of commercial purposes as well. What is the shortest path from us to another company? And it has a numeric different kind of a path. It has the kind of a information of how are we connected. If you look at the Fujitsu over there, who are we affiliated with? Who are the shareholders? What is the kind of a large volume holder of the company? And then the linkages to another company that actually influences our business by being connected as a relationship rather than being part of our company. So actually you are looking at know your customer. Let's assume that over here in the middle, we are not studying ourselves, but we would be studying a situation where we are making a major deal. How well do we know our own customers? How can we understand the semantically shortest path of who is actually the decision maker in that major project? We evaluate credibility of them in a similar manner. We even kind of predict different kind of corporate changes like mergers with that as well. We are working with human-centric intelligent society. So it means also there's a lot of our technologies that go into the quality of life. This is a experimental example of it where we kind of invest basically a simple hairpin just to show you that yes, we are interested in delivering common good, solving the major problems that we have. One of them is hearing impaired. So how the hearing impaired could actually feel when the mobile phone, you hear it, it's ringing. You hear that bling came from Facebook. You hear that different kind of a bling being your email. You might have another type of a sound indicator or light indicator giving your views that that's also a WhatsApp message. They need to have that information transferred to them, and that is done by them having the ability to feel the sounds. Since the technologies will be embedded everywhere so strongly, you will see algorithmic world change the society, or it will improve our capability to govern and control the services that deliver. It is just going to be extremely essential that we think about the transformation outcome first. We don't start with the digitalization project before. But with that embedded part of technologies across our society, and them getting relatively complex in the end of the day, We are in a situation that where you are the last generation to actually understand how IT works. So your kids, your grandkids will probably give you a question, what is a computer? It's going to be so dwelled into everything that we do with all the possibilities of improvements, efficiencies. We could take an example from healthcare sector where we have the ability to predict different kind of sicknesses. We even have a pedometer that we install to the angle of a cow to predict the estrus timing of the cow and 7 to 8 different diseases of a cow, just from the way that the cows dance. And they begin to step differently. We have an algorithm that reveals what that stepping means. It is the same as a farmer. If they are there physically, they know that that cow is not feeling well. How do we replace that capability with a scalable technology that helps us to focus on activities that are more important for ourselves? So that's the demonstration that I wanted to give you. The examples of existing business and operational scenery where we merge the richness of data from the physical world, from the open world, to the data that an organization possesses themselves, and create a far superior service models by transforming the operational model first, and then we can dwell with, okay, what kind of sensors are perhaps needed to actually digitalize something that today is analog. Thank you so much for listening. That was the transformation part, and I wanted to give you a heads up of. Hopefully you learned something. Thanks.